Hello students, myself Antara Ghoshal, Assistant Professor of ECE Department of Guru Nanak Institute of Technology. This is my lecture series on RF and Microwave Engineering. The code is ECE 701 and the course is under 7th semester of BTech course in Electronics and Communication Engineering Department. This is my contact number and mail ID. If you have any query, then you can contact me through mail. Now, the course name is RF and Microwave Engineering. Course code is EC701 and the total lectures for this course are 34. There are some course objectives. First one is distinguish the RF and microwave spectrum, planar transmission lines, and high frequency circuit elements. Second one is determine the microwave passive components and scattering matrix representation. Third one is illustrate the microwave tubes, semiconductor microwave devices. And last one is justify the microwave application and typical microwave test bench. Now, what are the course outcome? That means after completion of this course, the student will be able to understand the microwave frequency range and their application. They will be able to develop fundamental understanding of the two-port RF network and matching techniques. Learn the scattering matrix for microwave passive components. Also, they will be able to understand the microwave tubes and devices along with their fundamental principle of operation. Learn the microwave measurement techniques. Now, under module 2, there are different topics that high frequency circuit elements, difference in high frequency and relatively low frequency behavior of lumped circuit components, miniaturization and design of lumped components at a high RF, realization of reactive elements as waveguide and planar circuit components. Next, waveguide passive components and their S matrix representation of input networks, properties of S matrix, transmission matrix and their relationships, microwave passive components and their S matrix representation, and many other topics. Now, in previous lecture, I have already discussed about waveguide passive components and their S matrix. These are the S matrix representation for input network, which I have discussed in previous lectures. After that, there is S matrix representation for input network. There are 4 parameters, that is Y parameter, Z parameter, Y parameter, H parameter, and ABCD parameters. That was a Z parameter and Z parameter matrix and their representation. Next was Y parameter, the equation and the matrix and the parameters. Next was H parameters, same for H parameter, that was the expression and the matrix. Next was ABCD parameter, and that is the equation and in matrix form the equation. Now today we will discuss about properties of S matrix and what are the S parameters, etc. Now first, what is scattering matrix? This is a square matrix which gives all the combinations of power relationships between the various input and output ports of a microwave junction. Now the elements of this matrix are called scattering coefficient or scattering S parameters. Now if we consider this figure, then here the source is connected through the ith line, while A1 is the incident wave and B1 is the reflected wave. Ith source is connected through ith line and the incident wave is A1 and the B1, that is the reflected wave. And if a relation is given between B1 and A1, then it will be B1 equal to reflection coefficient into A1. Now already you know about what is reflection coefficient and how we represent it, that S1I, that is the reflection coefficient into A1, where that S1I is the reflection coefficient of first line, and one means reflection from first line, and I is source connected at ith line. Now, if the impedance matches, then the power gets transferred to the load. If the impedance matches, then the power gets transferred to the load. Unlikely, if the load impedance does not match with the characteristics impedance, then the reflection occurs. All of these about all of these topics already you have studied in AM theory and transmission line. Okay. Now, when the reflection occurs, that means the reflection occurs when ZL not equal to 0. That means ZL is a load impedance and Z0 is the characteristics impedance. Means when load impedance is not equal to Z0, that means if it does not match with load impedance, does not match with characteristics impedance, then reflection occurs. Now, however, if this mismatch is there for more than one port, then it will be for n ports, then I equal to 1 to n. Means I can be any line from 1 to n. Therefore, we have V1 equal to S11A1 plus S12A2 plus S13A3 plus up to S1NAN. And for B2, that was for B1. And if there is B2, then B2 equal to S21A1 plus S22A2 plus S23A3 plus up to S2NAN, and then Bn equal to Sn1A1 plus Sn2A2 plus Sn3A3 plus up to SNNAN. And if when the whole thing is kept in a matrix form, then we can write this like B1, that is the column matrix, that for B, that is B1, B2, B3 dot 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 up to Bn, equal to, this is the scattering matrix, that is S, is S11, S12, S13 up to S1n, next S21 up to S2n, and Sn1 to Snn, into next is matrix A, that is A1, A2, A3 up to AN. The column matrix B, that corresponds to the reflected wave or the output, while that B represents the column matrix, which that B corresponds to the reflected waves or the output, while the matrix A that corresponds to the incident wave or the input, and the scattering column matrix, that is S, which is in the order of n into n, that is n into n, that contains the reflection coefficient and transmission coefficients. That's why we can write that B equal to SA. Now, what are the properties of this S matrix? The S matrix is indicated as S matrix. There are few standard properties for this matrix. Their first is that S matrix is always a square matrix of order n into n. That is S n into n. Next is S is symmetric matrix. That is Sij equal to Sji. Also, S is a unitary matrix. That is S into S star equal to I. And the sum of the products of each term of any row or column multiplied by the complex conjugate of the corresponding terms of any other row or columns is 0. That is, if we take summation of I equal to j to n and sik star equal to 0 for when the condition is k not equal to 0. Means if the that means k equal to 1 to up to n and j equal to 1 from 1 to n, and if the electrical distance between the kth port and the junction is beta k ik, that is the electrical length, the coefficient of Sij involving k will be multiplied by the factor e to the power minus j beta k I h. Now, there are some properties of a two-port network. Two-port network, which I have discussed in previous lectures about what are the different parameters of a two-port network, that is Z parameter, Y parameter, H parameter and ABCD parameter. There are some general properties of a two-port network, that is reciprocal networks. Now, what is reciprocal network? The network is said to be reciprocal if the voltage appearing at port 2 here from the figure you can see that if the voltage appearing at port 2 is port 2 due to a current applied at port 1 is same as the voltage appearing at port 1, and when the same current is applied to port 2, and exchanging this voltage and the current results in an equivalent definition of reciprocity. And the network that consists entirely of linear passive components, that is resistor, capacitors and inductors, is usually reciprocal. But if it will not be reciprocal if it contains an active components such as generators or transistors. That means this is a reciprocal networks. Now next is symmetrical networks. What is symmetrical networks? When a network is symmetrical, then its input impedance is equal to its output impedance. Most often, but not necessarily, symmetrical networks are also physically symmetrical. These are networks where the input and output impedance are the duals of each other. And the next one is lossless network, and a lossless network is one which contains no resistors or other dissipative elements. Now if the impedance and admittance matrices, that impedance and admittance matrix are symmetric for reciprocal networks and purely imaginary for lossless networks. For scattering parameter, the S parameters are symmetrical if Sij equal to Sji, which I have discussed in previous slides. That was the properties of an S matrix, that is S is symmetric matrix, that is Sij equal to Sji. That is symmetrical matrix. And lossless if the matrix is unitary. That means the conjugate transpose of a matrix equal to the transverse of a matrix, that is A to the power minus 1. That means from this we can write that the conjugate transpose of a matrix into A equal to 1. That's also the properties of a matrix which I have discussed, that S is unitary matrix. This S into A star equal to 1. And in terms of scattering matrix, this can be written as S I equal to 1 to n S I j equal into S j k equal to, that is delta equal to 1 or 0. If j equal to k, then 1, otherwise it will be 0. Then the unitary matrix is lossless. Now, from the first slides, which I have discussed, that what is scattering matrix and the different properties, what are the scattering matrix and what are the properties of scattering matrix, and some properties of a two-port network and the relation of this two-port network with S matrix. And that's all for today. Thank you.